Okay, let's start today with lesson 7, which talking about the measure of variation or the standard deviation. Standard deviation and the variance are measures showing how much data values deviate from the mean. So why we call it standard deviation? Because I'm talking about how much data values deviate from the mean. So I have to find the mean. I have to find how much all the data are far away from the mean. So on this lesson here, we will learn how to find the standard deviation and the variance, and also how to apply the standard deviation when we use it. So today we will talk about the standard deviation and the variance. As I told you, both of them, which we call them measure of variation, that's other measures, show me how much data values are deviate from the mean. So deviation, measure of variation, I'm talking about which are variance and standard deviation. That's I'm talking about measures that how much values that are deviate from the mean. Now, also we'll talk about the Greek letters sigma. This sigma, that's mean the standard deviation. So here we have sigma and the variance. Sigma is the standard deviation, and sigma squared is the variance. Sigma as a standard deviation, sigma squared is a variance. Now let's see now how can we find the standard deviation. After you find the standard deviation, square the value, you will find the variance. Now let's see now here how can we find the standard deviation, or how can we find the variance. Then square root the variance, you will find the standard deviation. Here now, the first step, you have to find the mean or the x bar. After you find the x bar, you have to subtract or find the difference between each value and the mean. So after that, we have find the difference from each value and the standard and the mean. Sorry. Then we will square each value. Then we will find the summation of all these difference from the mean squared. Then we will divide it on the number of the data value of the data set. This one we have to find by this way the variance. Square this value, we will find the standard deviation. Let's see here now here. So let's now see that x bar, that's mean. This is mean. This is summation sigma. And this is the sigma, the standard deviation. Let's have an example here now. Let's see now how can we find the variance and the standard deviation. Step by step. What are the mean, variance, and the standard deviation of these values? Here we have 6.9, 8.7, 7.6, 4.8, and 9. So the values are 6.9, so we have 6.9, we have 8.7, we have 7.6. So the first step here, I make this table. After I make this table, the table must show x, that's mean the values, x bar, that's mean. Sorry, here we have bar. Here we have an x bar, that's mean. And mean. Here we have in the third column, you have to put x minus x bar, and here then you have to put x minus x bar squared. So if you want, or if I'm asking you to find the standard deviation, you have to draw this table. Then after that, you have to put these numbers here: 6.9, 8.7, 7.6, 4.8, and 9. So after we put these,
is there no need for the order here?
no need for order them. Then after that, now we have to find the x bar. Now, as we know before, how can we find the x bar or the mean? We have to add the values, the summation of the values over m. So let's find x bar. Let's add the numbers: 6.9 plus 8.7 plus 7.6 plus 4.8 plus 9. They are 37. So the summation here is 37 over how many values here we have? We have 5. So over 5, we have 7.4. So we have to write 7.4 here in each row. After that, as I told you, I have to find now the difference between each value and the mean. What does it mean? I have to subtract 6.9 minus 7.4. So 6.9 minus 7.4 is negative half. Then 8.7 minus 6.9 is, sorry, 8.7 minus 7.4 is 1.3. Then 7.6 minus 7.4 is 0.2. 4.8 minus 7.4 is negative 2.6. And 9 minus 7.4 is negative, positive 1.6. So this is the first step here. You have to find the difference between each value and the mean. Then after that, you have now to square these numbers. That means you have to find the square for each one. I told you, after you find the difference, you have to find the square of it. So negative half squared, or you can say 0.5 squared, which is 0.25. Be careful. They must be positive values. Don't say it's negative. Then 1.3 squared, which is 1.69. 0.04, 2.6 squared. It is 7.67, I think, or 76. Let's see here. 76.
Yeah, it's 76.
And the last one here, 1.6 times 1.6 squared, or 16 squared, which is 256. Half a point here, okay. So then after that, now, after I square each difference, I have to find the summation. So let's find now the summation. We have to add all of these values. 0.25 plus 1.69 plus 0.04 plus 7.76 plus 2.56. They are 11.3. Is it clear?
Yes.
Yeah.
Then after that, I have to find now. So after now, I find the summation here. I told you the summation of x minus x bar squared over the number of the data is the variance. So let's now divide 11.3 over how many data we have here? We have 5. So 11.3 over 5 is 2.26. This 2.26 is the variance. I found the variance, I found the mean. I need now to find the standard deviation. How can I find the standard deviation? Which is square root of the variance. That means square root of 2.26, which is approximately 1.5. Is it clear?
Teacher,
Yeah.
so this sigma, it's not the standard deviation, it is the variance, right?
Sigma squared is a variance. Sigma is a standard deviation.
Okay. Thank you, teacher.
Yeah. Now in this lesson here we learn by now we say that the mean is x bar. Later on we will talk about normal and binomial distribution. We will name the mean with mu. This one here, mu. So you have to know that sigma is a standard deviation. Sigma squared is a variance. Is it clear?
Yes. Yeah. Yeah.
Let's have another example now here.
So teacher, in each question like that, we should do this table, right?
Yes.
So
For each question you have to make this table, but I draw it to order or to arrange your work. Here we have 52, 63, 65, 77, 80, and 82. So I have to write here these numbers like 52, 63, 65, 77, 80, and 82. Then I have to find the x bar. To find the x bar, I have to summation. To find the summation of the values over n. So let's add them here. There are 419 over 6, which is 69.8. Then I have to find the difference between each value and the mean. So 52 minus 69.8, which is negative 17.8. Then 63 minus 69.8, which is negative 6.5. 65 minus 69.8, which is negative 4.8. 77 minus 69.8, which is 7.2. 80 minus 69.8, which is 0.2. And 82, it will be 2.2. 2 لحد ال 80, yes, 2.2. Then after that, now I have to square each one. So 17.8 squared, which is 316.84. 6.5 squared, which is 42.35. 4.8 squared, which is 23.04. 7.2 squared, 51.84, 0.04, and 2.2 squared, which is 4.84. After I square the difference now, I have to add them. I have to find the summation of this column here. So let's add them now as 316.84 plus 42.25 plus 23.04 4 plus 51.84 plus 0.4 plus 4.84. So what is the summation here? It is 438.85. Then after that, let's see that the variance is the summation of x minus x bar squared over n. So it's 438.85 over 6. So 438.85 over 6, which is 73.140. Then the sigma, it will be the square root of sigma squared, or the square root of 73.14, which is 8.5. This will be now the standard deviation. Is it clear?
Yeah, teacher, why do we use the standard deviation?
Wait a minute. By now I will tell you now. Is it clear now how to find the standard deviation?
Yes.
Yeah.
Okay. Now let's see now why did we use the standard deviation? Now as you see here.
What was the final answer?
Sorry?
What was the final answer?
8.5, I think. Yeah, 8.5.
Thank you.
Yeah. Now, most of you, if you look at the bag of rice, bag of sugar, what did you see? Sometimes you see that its weight is 10 kilogram plus minus 0.5 or 0.05 or 0.1 and so on. This one in manufacturing, okay, we called it standard error. What does it mean? This is standard error that when they make, or when they after making or after packaging the rice bag, or the bags of rice, sorry, they weight each one. They want now which one is acceptable and which one will be rejected. They will say that the mean of them, the mean or the average of all the bags must be 10. But as we know, our life is not ideal life. It's not a perfect. Sometimes we can't find it 10.1. Sometimes we find it 10.2. Sometimes we found it 9.8. Shall I reject all of these rice bags? No. They will put that. The manager, as an example, they say that I will put them like, but I will add 0.5 and you can subtract 0.5. What does it mean? That's mean here, if I find one of them 10.5 or 9.5, I will accept them. So between 9.5 and 10.5, it will be acceptable. That's why sometimes you will find on the back of rice that's 10 plus, if you find it plus 0.5, it will okay. If you find it 9.5, it will okay. So after they measure each bag of rice, they will find that maybe 10.3 they will acceptable. Okay, I will accept it. 10.5 it will accept, but they will find like 11 or 12 is not acceptable. I cannot give I cannot sell a bag of rice that is 12 kilogram or the customer, they found it as 8 kilogram. How the customer will be reliable of our market or of our place. So I must make him reliable of my products. To find that when they want to buy it as a 10, the net value or the net measure or the net weight as 10 kilogram, they have to find it as 10, 10.5, 9.5, it will be acceptable. But if they found it as an 8 or 7 kilogram, they will come back or it back to our markets. Then, so this is the standard error. Now, how did they found the standard error? By divide the standard deviation over the square root of n. When all of these informations are not in this one, I will not ask you. This is the information I told you about them because of my major in the university. As I told you, I'm industrial, so all of these statistics I know. I talk about them. We talk about manufacturing and how to say that is acceptable or rejected. This is an extra information, but for you, how we win. So this number here that you found it in the products. It is a standard error. How did they find the standard error? By find the standard deviation over the square root of n. How did they find the standard deviation? They measure all the weights. They have all the weights of the bags. After they measure them, we did as we did here. We find the mean. Then we find the standard deviation. Then after that, they divide the standard deviation of the square root of the number of bags to find the standard error. This is why we use the standard deviation. Is it clear?
Yeah.
Okay. The others, is it clear?
Yes.
Okay. So that's why here sometimes you see like as a example the bag of sugar. It is 5 plus minus 0.02 as an example. What this mean of plus minus? طبعا إن شاء الله next lesson in binomial and normal distribution we will talk about them in more details. So here now let's see how we can use the standard deviation to describe the data. That's mean I will put as an example, me as a teacher now, I will put this one for me here like this. It is a build shape, but I know I am not cannot draw it clearly. Now I will say that the mean or the average of your class is 10 from 20 or 10 from 25 as an example. Then I will say that okay, if it is less than, you say now mu or before sigma mean minus standard deviation, and here we have sigma plus 1 standard deviation. Then I will say all the values that is less than or greater than 1 standard deviation will be acceptable. Or another, this is for me as an example. For other teacher, they say, oh, she said, I want all the scores that's greater than mu or sigma minus standard deviation. So I used the standard deviation to describe the data. Let's now here have the United States hurricane strike from the problem 2. Okay, here the table display the number of United States hurricane strikes by decade from the years 1851 to 2000. Every decade, now you know that the decade is 10 years. So every 10 years they measure or measure or count how many strikes we have from 1851 to 2000. In the first decade, we have 19. In the second, we have 15, 20, 22, 21, and so on. I want now to find the mean and the standard deviation for this data set. And after we find the mean and the standard deviation, I want to find now within how many standard deviation from the mean do all the values fall. So let's first find.
Teacher,
Yes.
teacher, before this one, you drew a plane. Can you repeat it? Did you say it's minus or plus? I don't know what. The
This
one
one?
that you did before this one. Can you repeat this one?
Okay. Here, I told you that if I am like, as an example, like, give you another example. Okay, as an example. When I measure my weight, I found that my weight 70 kilogram. Or the mean of my weight is 70. Then I will say, okay, sometimes I can be 71 and sometimes I can be 69. That's mean sometimes I can be x bar plus sigma and sometimes it can be x bar minus sigma. And this sigma, that's we found it. Now, then I will say, okay, when I measure it, if I found it between x bar minus sigma and x bar plus sigma, I will say that this is acceptable. But if I find it greater than x bar plus sigma, I will have to make a stop as an example and make a diet. This is the meaning of it.
Yeah,
okay,
thank you so much, teacher.
Yeah. So let's come back here now. We have a table of these 15 data. I want to find the mean. I want to find the standard deviation. And I want to find within how many standard deviations from the mean do all the values fall. So let's find now here the standard deviation. Let's make a table now as 19, 15, 20, 22, 21, 18, So let's have here an x values. Here x bar, here x minus x bar, and here x minus x bar squared. So we have 19, 15, 20, 22. Hanini, please find the mean while I am writing.
Okay.
18, 21, 13, 19, 24, 17, 14, 12, 15, and 14. And here you have to find the summation. Now, let's now wait Hanin to find the mean.
And teacher, all of them, how much are they?
15.
They are 15.
It's 17.6.
So it is 17.6. Now so here all of them is 17.6. Let's now subtract 19 minus 17.6, which is 1.4. 15 minus 17.6, which is 7.4. Then 20 minus 7.6, which is 3.4. 22 minus 17.6, it is 4.4. 21 minus, so 20 minus, here 2.4. Here 3.4. Here is 18 minus 17.6, which is 0.4. Here 21, we have 3.4. And 13, we have 5.4. In 19, we saw this before, which is 1.4. In 24,
Teacher?
yes,
Teacher, 13 minus 17.6 equal negative 4.6.
wait, please. Suppose I have 13. It's negative 4.6. And so on, okay? Then you have to find the summation of them. Square them here, as we know before. 1.4 square. Shall I continue, or you get the idea?
No, I get the idea for me.
So after that, you find them. You have to find the summation, divide by the number of them. You will find now the standard deviation and the mean. This is the first step. I find the standard deviation. I find the mean. Now, the question was, within, yeah, now within how many standard deviation from the mean do all the values fall? So what you have to do here, we have to make a number line like this, and you have now to represent each one. Yeah, I mean, we have at point 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Then after that, how many 10 we have? There is no.
6.
How many 12? We have 1. So we put X for 12. How many 13 we have? We have 1. How many 14? We have 2. So we put 2 dashes like this, or 2 points. How many 15? We have 2. How many 16? There's no. How many 17?
How did you know?
at here. How many 17 you have? 117. So we put 117. How many 18? We have 118. How many 19? 1 and 2. How many 20?
1,
We have 1. How many 21?
1.
21. There are 2. 1 here and 1 here.
Oh, 21.
How many 22? We have 1.
1.
How many 23? There is no. How many 24? There is 1. After that, now, after we present them here, we have to say, now, what was the mean? It was 17.6. So, at 17.6, approximately it is here. Here we have the X bar. So here we have the X bar. Now, so here where's the X bar is 17.6. Now, we said that after we solve it, we found that the sigma, or the standard deviation, it was 3.5. So you will say now 17.6. Okay, you have to add it to 3.5. What did you have? 21.1. So at 21.1 here, we have an X bar plus sigma. Then subtract 17.6. Subtract 17.6 from 3.5. What did you have? You have 14.1. So at this point here, we have an X bar minus sigma. Then let's find now an X bar plus 2 sigma. What is 2 sigma? 3.5. 2 sigma, that means 7. So if you add 17.6 to 2 sigma or 7, you have 24.6, which is here.
Teacher, why you make it 2 sigma?
This is the in statistics. You have to find mu plus sigma, mu plus 2 sigma, mu plus 3 sigma. And mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. You have to find the 3 sigma above and 3 sigma down.
Okay.
Then here you have x minus sigma. Then x minus 2 sigma, that's mean 17.6 minus 7, which is 10.6, approximately here. And then you can find x plus 3 sigma and x minus 3 sigma. Now, the question is, within how many standard deviation from the mean do all the values will be acceptable? Within how many standard deviation? All the values will be acceptable. Within how? You will look at, here you find mu plus mu minus 3 sigma. That's mean 3.5 times 3 minus 17.6. Here we have at point 7.1. So 7.1 or 10, there's no value